we're not learning any more methods to solve these. Today what we're going to do, methods of solution, lesson 12.5, is we are going to start putting these 4 different methods together and starting to figure out which method works the best in which situation. So, your book has this. I'm going to be giving you a little summary of it here. We're going to number the different methods that we used. And each of them comes from a different lesson. I will put, in addition, I don't think the book mentions this, but what I will do is after each one of these methods, I will tell you which lesson of the book it came from. They're not necessarily in order, so. Quadratic formula, right? The negative boy, the radical party, all that stuff. Now, here's what we're going to do. On the left side, I'm going to put the method. And on the right side, when to use that method. When would this method be the best? And by the best, I mean it would make the most sense, it would be simple to use, okay? Now, you don't have to use any particular method for any problem. But what this lesson is about is that certain methods are easier in certain situations. If you want to make it easy on yourself, you're going to want to try to follow this. Okay? So, when do we want to use the quadratic formula? First of all, when you want to use your calculator. Now that's simple. Of course, you get to use your calculator here for pretty much everything. But the other thing is when the equation either looks like this, or you could easily make it look like this. And like this, I mean equal 0, everything on one side, and it's a trinomial. So if you have ax squared plus bx plus c equals 0, or you can make it look like that, you know, maybe this c, this number value was over on the right, but all you had to do was subtract it over and now you have it on the right, on the left side, then that's going to be a good time to use the quadratic formula. Okay. Now, step 2. We haven't done a lot of this lately. In fact, this was not, we haven't reviewed it in this chapter, but I'm going to show you an example of it. Don't hate on factoring. We have done I shouldn't say we haven't done it this chapter. We haven't really focused on it. A lot of this, I'm just going to put chapter 5. What we have done in this chapter is we have looked at the special patterns square of a binomial. Okay? And so that's really the factoring that you're going to be doing here. Let me see here. In chapter 5, if I can find it here. It's 5 or 5.6, I think. Let me see. 5.6. 5.6. There we go. That's more specific. So it's not just all the kinds of factoring, but especially the kind of square of a binomial. So if you see this pattern, then this would be a good method to use. If you see the square of a binomial pattern, and again, I'm not going to write the whole thing here, but this is where we have this, and it's a squared plus 2ab plus b squared, that part, I don't have room for it. You can look at 5.6 in your notes. So that's one thing. If you see this pattern, let's separate these here. Or, if it looks like this, now I haven't specifically focused on this particular pattern. Notice what's missing. There's no plain number. In a situation like this, I'm just going to remind you here of the notes because we haven't done this particular kind of factoring in a while. If there's no plain number, we could factor an x out of here. And then we'd get this. And then I have 2 factors, right? I took an x out of both of those. I factored it out. And then I have 2 factors that multiply to equal 0. I don't know which one equals 0, so I'm just kind of showing you a review of how this would go. You'd set each one equal to 0, and guess what? Then you're going to get 2 answers. So we take our first factor, set it equal to 0, solve, take our second factor, because if they're multiplied and they equal 0, one of them must be 0. I test them out both, I get my 2 answers. So I'll show you an example of that when we get to some sample problems here. Factoring. Okay, method 3. square roots. They describe it in the book as using the property of square roots of equal numbers. Huh? I like to just refer you back to lesson 12.1. This was the beginning of our chapter where we had equations with perfect squares. If it looks like this, and if you look back at 12.1, you'll see that we often did not have trinomials. Now, of course, the plus could be a minus, but notice what we're missing is the middle term, the plain x. We've got something squared, so there's a perfect square. We take the square root of that x eventually, but first we undo the other things. So if you're missing that plain x in the middle so that it's not a trinomial, then you might want to use that method from the first chapter of this book. Last method, and I don't know why they have them out of order, but they do, completing the square. And this was lesson 12.2. Completing the square. For this, notice the difference. I'll put this back up. Notice the difference between this one, where my finger is, and this first one, an a. If you have a value in front of the x squared and a value, you might want to use the quadratic formula. You could use the quadratic formula for this, but I'll tell you on the test there will be problems where you have to complete the square. So I'm going to suggest today that if you see one in this format that you practice this method, because there will be some that you have to do this way when we get to the test. Now, what makes it easier to do completing the square? Where b is an equal number. Remember that we had to fill in that third spot for completing the square, we did b over 2 squared. And when it wasn't an even number, when b was an odd number, we ended up with these big old fractions. Well, guess what? Then maybe don't use that method now that you have other choices. If b is an odd value and you're going to keep this funky fraction, then don't use that method. Use it when b is an even number because then it makes it a lot easier to work with. That's it. 4 different methods for solving. Now, here's what we're going to do. I'm just going to show you a couple, and we're going to decide which of these 4 methods would make sense by looking at the patterns. Okay? So, what we're going to do is we're going to start by just identifying them as method 1, 2, 3, or 4. And in your homework, I'm going to be asking you to do the same. I'm going to say, you can just say 1, 2, 3, or 4. You don't have to use all the words. But I'm going to ask you, which scenario does this match? And which method do you think would be the best? So first example, 12x squared minus 108 equals 0. Which method do you think that matches with? Daniel Q?
Square roots.
Okay, method number 3, right? So here's what, you could write square roots. You don't even have to write the word method if you just want to say number 3. This goes with method number 3, square roots, right? Because what Daniel noticed is there's no plain x in the middle. Now, let's go ahead and solve it. This is from lesson 12.1. What are we going to do? We're going to start getting the x by itself. I leave the x alone to start. I add 108 to both sides. I get 12x squared equals 108, right? So I'm going to show you how to solve each of these using the different methods. Just a little reminder. Next, I divide by 12. 12 isn't being squared. So I want to undo that. I get x squared equals 9. Now I can take the square root of both sides. Don't forget the plus and minus. There's my 2 answers. Okay, so for that problem, we go, oh, method 1. So what I'm going to be asking you to do on the homework is to tell me which method did you choose, and then you go ahead and solve it using that method. Okay, questions on that one? Next example, 4x squared minus 12x plus 7 equals 0. What does that seem to match with according to my notes that I gave you? Diego?
Method 1.
Good, we are going to use method 1. the quadratic formula. You could complete the square, but let's go ahead and try to match it up and use the method that matches. So x equals a negative boy, the opposite of negative 12, right? A negative from the formula, a negative in the b, that makes positive 12, plus or minus the square root of 12b squared, negative 12 times negative 12, minus 4 times a times c, all over, oops, I put 2a, let's put the number in, 2 times 4. Sorry, I wrote the variable. We want to get rid of that and put the number in. 12 plus or minus, I do all of this math first. 4 times 4 is 16, and 16 times 7, I get 112. It's going to be negative or minus. So 144 minus that, I'm just doing the math a little more quickly here. If you have any questions, let me know. I'll go over it with you. 32, all over 2 times 4, 8. Again, we're going to simplify that. 32. You could do 4, but I'm going to do 16 times 2 instead, because 16 is a perfect square. The square root of 16, 4. Still have my root 2 underneath. I still have that 8 in the denominator. Final step on this one, the 12, the 4, and the 8 all share a factor of 4. If I divide all those whole numbers by 4, (12) divided by 4, 3. 4 divided by 4, invisible 1. 8 divided by 4, 2. Simplify it down as much as you can, leaving the irrational square root. So, quadratic formula. Again, if I went fast and you're not sure how I got the numbers, just ask me. Otherwise, since you guys seem to be pretty good with that formula, I was doing it fast. Okay. Third example. Good on that one. We're done. Third example. 4t squared minus 56t equals 0. Which method does it look like it matches with? I'll point out there's no c. We're missing the whole number. Luke?
Method number 2.
Okay, good. We are looking at number 2, the factoring method. Now, I know we haven't done this in a while. This one is not the difference, the square of a binomial pattern. So I'm going to show you on this one. I'm going to remind you, and by the way, this is a give review for finals. What can I factor out of both of these two terms? What's common that I could divide out? CJ?
4.
Okay, good. Now, if you're not sure about the 4, test it out. 56 divided by 4. Oh, yeah, I don't know if you can see that. That's a 14. We can take a 4 out. What else? Leanna? Good. I can take one t out. And then I look to see what's left. If I divide out a 4 and a t from the first term, I'm left with 1 t. 56 divided by 4 was 14. T divided by t, I already took the t out. There's no t left. If you forget this and you're looking at it going, huh, come see me after I'm done. I'll go over it more slowly with you. Okay? Now, the final step. I have two factors. I have the 4t. Hey, maybe that one equals 0. I have t minus 14. Hey, maybe that one is the one that equals 0. If I have these two things being multiplied, one of them must equal 0 if my answer is 0. So I take each factor, I set it equal to 0, and then I just solve. Divide by 4, well, that's just going to still be 0. 0 divided by 4 is 0. On this one, I add 14 to both sides. T equals 14. There's my two answers. Now, again, we didn't do a lot of that in this chapter, I know. So if you've come across any factoring, please try them in your homework as a refresh. I can help you with it if you get stuck. Final one. You can probably guess what method we're going to use. It's the only one we haven't gotten to yet. N squared plus 8n minus 2 equals 0. Method number 4, completing the square. There's no a value, and I have an even b. Let's try completing the square. Now, first, 2 is not a perfect square. This is where we're looking at that square of a binomial pattern. If this is not perfect square, 2's not perfect, I move it over and I leave this blank spot. And so that I don't forget, whatever I put in that spot, whatever I add on, I gotta put it on the right. So I'm gonna go ahead and give myself the blank spot on the right side as well. Otherwise, I know I will forget. Next, the pattern. To find that third spot, to complete the square, we take the b value, we divide it by 2, we square the whole thing. In this example, my b value is 8. 8 divided by 2 is 4. 4 squared, 16. I add it to both sides. The goal of this is that I now will have the square of a binomial. N squared, the perfect square of n times n. 16, the perfect square of 4 times 4. I now have a binomial square, which means I can take the square root to get rid of that exponent. That leaves just n plus 4 on the left. On the right side, I'm going to put my plus minus to get started. Now, let's take that 18. I can factor that down to 9 times 2. 9 is a perfect square. Square root of 9 is 3. So I simplify the right side and I get plus or minus 3 root 2. On the left side, I still have n plus 4, so my final step, subtract the 4. If you want to just leave it like that, that's fine. I will accept plus or minus 3 root 2 minus 4. I will generally, in the book, will show the answers putting that whole number, that single number first, so negative 4 plus or minus 3 root 2. This is also correct. I'll take either one of them. That's completing the square. So, here's what you're going to do. You're going to, on the homework, for each problem, you're going to tell me which method do you choose, and then you use that method to solve.